This is one of those physics videos you want to save for later. Very interesting and you will love it. Let us solve this exercise together. I am just going to represent this question here in the form of a diagram, and that is what you're seeing here. So let me explain. The question says that there is a pulley and we have masses of 6 kg and 4 kg tied to a string and hung over a frictionless pulley. This string is a light string according to the question, so that it does not account for the mass that is going to be used in this exercise. As you can see, the masses are 6 and 4. They are not equal, which means there is going to be a movement in this direction. That movement will create an acceleration, and the question is asking us to find the acceleration of the system. Not just that, we'll still go ahead to calculate the tension in the string. Join me as we solve this problem. You would have noticed that the masses are not the same, so we are going to identify them as mass 1 for the 6 kg and mass 2 for the 4 kg, M1 and M2. Because of the change in the mass or the difference in the mass, there is going to be a movement in this direction. So the system is going to slide down this way because of a net mass or a resultant mass in this problem. That net mass or change in mass will create what we call the net force that will be acting on the system. So to start, let us determine the change in the mass. The change in the mass delta M is equal to M1 minus M2, and that is simply 2 kilogram. So a change in mass of 2 kilogram will result to an acceleration of the system. So let us determine the net force that is creating that acceleration. The net force will be the product of the change in the mass and acceleration due to gravity. Remember, in terms of weight, every mass possesses weight that is acting downward. In this case, if this was a 6 kilogram object balanced by another 6 kilogram object, you wouldn't see any movement. Because there is a difference, then there is a change in mass and a net force. So that net force is equal to 2, the change in mass, times 10 to give us 20 Newton. Considering that we are taking acceleration due to gravity as its approximate value of 10 meters per second square. Now that we know the net force acting on the object, we can then determine the acceleration of that net force, considering that the total mass acting is 6 and 4. So we have a total mass of 6 plus 4 to give us 10 kg. So with this 10 kg, we can determine the acceleration to be the net force divided by the total mass, and that is 20 divided by 10 to give us 2 meters per second square. So it is with this acceleration that this 6 kilogram object is moving down. It is with this same acceleration that the 4 kilogram object is moving up, because eventually both masses will be moving downward. Now let's go to the next page to calculate for the tension. So this is the system we've got. We've just calculated the acceleration. For the 6 kg mass, the acceleration is 2 meters per second squared downward. For the 4 kg mass, the acceleration is 2 meters per second squared upward. But eventually, the acceleration is in a uniform direction in this order. Now, let us go further to identify other forces acting on this object. We have to calculate the tension, but first, the 6 kg mass has a weight. Let's call it W1 because we are considering it as mass 1, and the 4 kg to be W2, representing the weight due to mass 2. Now, tension is the counteractive force that acts against the weight of the object, but is just enough to provide the needed acceleration. So being counteractive, it means while the weight is acting downward, the tension will be acting upward. Similarly, on this one, while the weight is acting downward, the tension is acting upward. You can see that I didn't use T1 and T2 because the tension will remain the same. However, the tension would be considered in isolation of the masses, because the 6 kg creates a tension by its pull, considering an acceleration of 2 meters per second squared. Also, the 4 kg creates a tension that also pulls it up, considering a 2 meters per second acceleration. Combining this, we can now determine the tension in isolation of mass 1, and that will give you the same answer as the tension in isolation of mass 2. So we are going to consider it first for mass 1, and the answer we are going to get will be the same if we considered it for mass 2. So you are free to use either mass 1 or mass 2 to determine the tension. But in this video, I'll be considering both so that we can see how it works. For mass 1, what is the tension? The tension opposes the weight, which means the tension should be equal to the weight. However, the object is still moving at 2 meters per second squared, so the tension will be reduced by the force moving the object at 2 meters per second squared. Hence, we can say the tension is equal to the weight 1 minus the net force that is moving the object by 2 meters per second squared downward, so that the tension will now be m1g minus m1a, where g is acceleration due to gravity and a is the acceleration of the object. 6 kg is the mass of that object. We are considering mass 1 now. So we have 6 times 10 minus 6 times 2, and that is 60 minus 12 to give us 48 Newton. What it means is that the tension that is counteracting with the weight is 48 Newton, but at the same time, it also allows the object to move down at 2 meters per second squared. Now let's consider mass 2. You will discover that the tension will also be 48, so let's go. In this case, the tension is counteracting with the weight W2, or with the weight W2, but it also makes this mass to move up at 2 meters per second squared. What it means is that the tension is doing more work. First, it needs to balance the weight. Then 2, it needs to be increased to be able to lift the object. So for this one, the tension will now be the weight W2 plus the net force for which this object is moving at 2 meters per second squared. So we have m2g plus m2a. Putting values, 4 is the mass times 10 for the acceleration due to gravity plus 4 times 2. Remember, 2 is the acceleration. 4 times 2 is 8, 4 times 10 is 40. 40 plus 8 gives us 48 Newton. So you can see that the tension is the same. Whether you consider mass 1 separately or you consider mass 2 separately, you are going to get the same answer as tension. So feel free to use any of them in your calculation. But for purpose of explanation, I have done both to clarify the need to solve with either of them. Take note, if this was an object that is dropped into a well, you will discover that the tension will reduce. The 6 kg is as if you are dropping an object inside a well. The tension is less. But if you are lifting the object from the well, the tension is more because you are opposing the weight of the object and you are also moving the object up with an acceleration. And that is what we have just considered in this exercise. I hope this video was clear enough and it was educative. If you love it, like, share, and comment. Follow our page if you have not done so. And if you are watching this video on YouTube, consider subscribing to our YouTube channel and hope to see you in our next video.